Good afternoon. I'm Adam Riley, Director of Engineering here at Enso, and I'm with you today to look at solving Preppin Data 2024 Week 12 in the Enso product. So we're back to prepare scenario this week, and we've got a student loan repayment exercise. So I have been through this exercise before this, so I'm rebuilding it for you, having already solved it once. And today we're going to look at some of the very unique features of the Enso language that perhaps be very different the way you'd solve this in other visual programming languages. So although Enso can work with tables, as you know, all visual programming languages tend to use as their step, Enso is also able to work with any types of data connecting between the components, and we'll see that as we get started with the workflow. So first task is to input the data. So I've got the data downloaded down here in the bottom right. I'll drag and drop that onto the background as usual and remove our starting node. So we've got a couple of worksheets in here. So we need to start up with the undergraduate loan table. So I'll bring in the read component and undergraduate loans, and we'll just take a look at the data in there. So we've got a couple of loan type, course start date, course years, and amount per year. Okay, so first thing we need to do is create a row for every year of the course. So each of these courses is 3 years each, and we need to create a row for each of those years. And I guess we need it to be each date. Okay, so do this, Enzo, using we're going to create a range of the dates for each row, which we need to do using a map function. And then once we've got the range, we can expand the range down to rows vertically. So let's take a look at what that looks like. So first thing we do is grab hold of the rows objects that gets this table as a vector of rows. And what we're going to do is build out a function that works on first row. So I'm going to use the at component and do at 0. This gives me the first component, the first row in that table. And you can see if I hop on the output port of this component, the output type here, so it isn't a table anymore, it's a row. And what that means is I can then grab the course start date from that row. So if I use the at, I can use the drop down to get the course start. Now, of course, there's going to be a string field. If I want to do any date time manipulations, I'm going to need to pass that into a date time. So if I do pass date, format, right, what is it? So it looked like this one, but without the D on the front. So just do that. So that's passed that value as the call start. So if we look at this now, we've got a date in there. So 1st of September 2020. And again, if we hop on that output port, we can see this is now a date value. For the date value, we can use the up to command. So it's going to create us a range. And we want to go to the end, which is going to be 3 years after the start. So I can create another component on here that is date add. Period is years. Okay, and you can notice the amount now is a number. And so they're using one of the cool features of Enso. I can go back to my row. I can put another act component here. I can choose the course length. That then gives me the value there. And on the type, that's an integer. I can take that integer, plug it into this, and that's going to add 3 years onto my data. So 2023 now. So that's looking good. And then if I plug that into my range, so I've now got a range of dates, and I want one per year. So in here, I can set the step to years. I have a default to today, but I go to years. Great. So that's given me a range for a single row. So did all this on a single row. What I want to be able to do is do that for each of those rows. And I do that with something called a map function. So if you're familiar with functional programming, then map function will be something you're very familiar with. If you're not, it's a new concept that you'll learn as you get into the more advanced parts of Enso. So to do that, I first need to clap these nodes down into a function that I can run for each row. And there's a slight defect, of course, I discovered while working on this problem. So you're going to have to excuse the slight workaround I do. I just need to create a single entry for my node. So the defect is if I try to create a group of nodes with multiple entries, it doesn't work properly. So I've just created this is literally a copy of the data that's in here. So out here it's still the same row, but it's just a single entry point. So now I can grab all of these components. I do Control G, and that collapses those down into a function. So you might have seen this functionality before in Enso. If I want to see what's in there, I can double click, and there's the contents of that, and see the breadcrumbs at the top and go back to the main project. Um, okay, so now I've got that function. I can apply it to each row of this table using the map command. Sorry, map runs over rows, not on the table. We need to add it to the table with a future enhancement. So grabbing the rows object, that's a vector, the rows of the table. And then what I need to do is create a copy of this. So I'll leave this one over here on the side. So I want to come and edit it later. I've got the easy one to double click onto. This one, I'm going to go into code edit mode. I'm going to remove the incoming connection there and replace it with a underscore. So underscore is the placeholder that says I'm going to pass something in there. In this case, it'll be the row. And then this now is a function. So I'm going to pass it into the function parameter on my map component. What the map component does is runs this function for every row that it finds in this row object. So in this case, there's two rows, but obviously you could do it for multiple rows. This way it's running a thing over a table. So if we look at that now, we can see we've got the vector of date ranges. So for each row, we come to the vector. And the last thing we want to do is set that back into a new column on the table. So I'm going to use a sac command for that one. Close that up, drop it in there. And we can now give it a name, and we're going to call it, we're creating payment date field. So let's call it payment date to match what we've got there. Great. And then, so if we can take a look at what's coming up there. We've now got this payment date field. This is a range. And with that range, I can then expand it to rows. And that's going to give us the, hopefully if I've done it right, it's going to give us, there we go. So we've now got a row for every year of the course. It should fall on September 1st, which it does. We've got 1st September 2020, 21, 22, and then the same again for the second part of the loan, which is the maintenance loan. So that's the first bit done. And I'm going to use the collapse nodes function again. And again, you have to excuse me as I work around the defect. You're going to see this a few times today, unfortunately. It's creating a copy of that incoming data. I've got a single entry point to my group of components. We will fix this defect very quickly and tidy up the inside of this a little bit before I close it away. Okay, so then I'm going to grab that whole lot of nodes, do a Control G as my keyboard shortcut. That collapses it down, and then I'm going to grab the text over here, and I'm going to add that comment on there. So when I come back later, I know what that's doing. Okay, so that's the first step done. So the next thing to do is calculate the number of months between the payment date and April 2024. So usually when I'm working in Enso, I tend to reach for the set component in this case, and then I'll write uh, a formula expression in the set that would be the difference between the dates. Again, I'm going to do things a little bit differently today, just work in a different way in the Enso language and just show you what that looks like. There's no particular better or worse way, it's just personal preference. So we need to calculate the months between the payment date and April 2024. So I'm going to grab the payment date column. So the at command, I'm going to choose payment date. And then I want the difference. So it's going to be, if I type in diff, got the date diff component. And then the end date, well, that's going to be April 2024. So if I click on the background, press the enter key to create a new node. And I just want date.new. It's going to let me create a date constant. So April 2024. And that's going to be the end period for this date diff. And it's the number of months I want. So period, I'm going to choose month. So this has given me a column. I now need to put that column back onto my table. So again, I do that using the set command. So we're going to see some sort of repeated patterns as we build this workflow out. So drop that down there. And I'll call that number of. Great. And let's check that doing what we want. If we go across the right-hand side of the table, so we've got the number of months and the payment date for each of these parts of the loan. So again, I'm going to collapse these nodes down just to keep tidy as I go. Again, we're doing this little workaround that, and we'll grab that sort of node, Control G, and calculate the number of payment dates. There we go. They're going to be coming for that block. Okay, so next up, we want to join with the repayment details table. So I'm actually not going to do this step. So this is something that you do in a language where everything is tables. If you need to bring data together from different tables, then you join it and then you pull the field across. It ends there because I'm able to access different elements and types. I can, what I need out of the repayment details table, having done this exercise earlier, is the interest rate, which is on the second table, but I can actually pull that interest rate out as a constant. So let's see what that looks like. So if I again pull off my Excel work, add a read component. So I want the repayment table this time. There's two rows in this repayment table. I couldn't see from the exercise which one I was particularly supposed to use. I went for the undergraduate, which got me to the right answer. So I'm going to do that again. So filter the loan column equals a text constant, and the text constant is undergraduate. So that just filters it down to a single row. And then again, I'm going to do that same trick of getting the table as a vector of rows. And then from there, I can take the first row. I mean, in this case, there's only one row, but I want to get to the first one. Because once I've got a single row object, I can then pull a single value out of that row. In this case, the interest rate. And if I visualize that, I can say, here's the interest rate, and hovering over there, we can see that's a float. So this is a numeric constant. Okay, so that's great. That's perfectly got me prepared for what comes next. And that's calculating the amount borrowed plus the interest. And they've provided us with the compound interest formula here, which is useful, which is so A, which is what we're going to calculate, equals P times 1 plus R over N to the power of NP. So the interest is in this formula is the P. No, it's not. I can't read the code properly. I can't be good at all at it. Um, right. R. R is the nominal annual interest rate. Sorry, my eyes are not very good today. So I need to take the interest divided by n, which is the compounding frequency. So it's monthly in this case, that's 12, and I need to add 1. So I'm going to do that to the constant here. So that the interest divided by 12 plus 1. And we can see that calculating as we do it. So there's the answer down there. Looks plausible. Okay, so that's the bit inside of the bracket. And again, that's still a constant. We now need to raise that to the power of the compounding frequency multiplied by the overall length of time the interest is applied. So that's going to be, if we open this table, for each row in here, so the number of months. So we need to raise this value here to the power of the number of months. And we're going to do this again with another map function. So we're going to pull out the number of months column. We're going to add a map function. And so now we need to write a function that we're going to apply to each value in this column. And we'll do that underneath here. And it's going to be this value to the power, and then we're going to do an underscore here, which we saw earlier, as a placeholder for the value coming in from the map. So I press enter on that. So this is now a function. It doesn't evaluate to a value. If you look in the visualization, it's a function, which is exactly what we want. If we put a value in there, it would evaluate it and give us the value. And then I drag that function onto there, and that's going to create me a new column, which is all of those values raised to the power of that value there. And then the last thing we need to do is multiply that by P, which was the original value. So in this column, the original value is the amount per year. So this is how much the loan was each year. So again, I'm going to grab a that's here. I'm going to grab the amount per year column and I'm going to multiply. And again, I'm going to put a placeholder in there so you can see the placeholder, and then I'm going to use that placeholder to map. So it's a doc that map into. Okay, so then this here should be a column, which is the amount per year times the result of this. And so the last thing to do now is do a set function back on our table. So similar pattern to what we did before. Bring that down here underneath. I'm going to put the column into the value. And the name for this is going to be down to the final result. It's going to be total borrowed plus. Okay, so that completes the next bullet of calculating the amount borrowed and the interest applied. So again, I want to flap this down. So again, I need to get a single entry point here. Just that. So that's the one. This one is going to have two entry points. The second one's going to be, I think I'm going to take the first row. So I'm just choosing where I want to put the group in, because I'm going to need some values from this first row for the next section. So I think if I now grab that chunk of components and do a Control G, and again, just move that up. and I'll take the instructions to make that my comment. Okay, so again somewhere. Um, Next thing, total these values together so only one row remains and graduate can clearly see the total amount they borrowed and where it stands now that interest has been applied. Okay, so for this we want to do a aggregate. So this is back to much more standard stuff that we've done previous week. And we want to do a sum of the amount per year. That was the total amount they borrowed to start with. And then if we do a sum of the total borrowed and interest, then that's going to give us the total value of the loan now. So if we look at that, so we can see in this example, initially we borrowed £45,000 and we now owe £55,000 after all the interest has been applied over how many years. Let's rename on that just to keep the column names clean as we go. So some amount per year, that is total borrowed, and the sum total borrowed and interest in the final table. They don't have the sum, so that just gives it a little bit closer to what we're going to need to get to. Okay, and again, I'm going to group these two up. I don't necessarily need to, but it's just going to keep this level of the workflow clean and consistent. And right, take that comment for the. Okay, so now I need to introduce a salary parameter with values of potential graduate salaries. Thing parameters are a Tableau prep thing. I don't have the exact equivalent in Enso, but what I do have is I can create a numeric constant. So I click on the canvas, press the enter key, and I can type in £30,000. Press enter. That just creates me a integer constant, and then I can use that. I can change the value in there if I'm a different person coming in, entering a different salary amount. So now I need to work out what the monthly repayment will be based on the above information. And that comes again from the data that's in this repayment table. So reminding ourselves of what's in here. We've got this repayment threshold. So you pay back anything that goes above the threshold and you pay it at a rate of this percentage here. So 9 in this case. So again, I've got this first row table, so I can just start building up here. I can do a and grab the repayment threshold. And I can do a second over here and grab the percentage over the threshold. Okay, so in terms of working out my monthly payment, it's going to be my annual salary minus, after that underscore placeholder prick, and then I can dock the repayment threshold in. I can see the results there. Again, I could have done this in a more traditional sort of Excel style formula. As I said, today I'm just using some of the different ways of working it in there to see how it feels like solving this particular problem. Okay, so this person is earning 2,705 over the threshold, and then they need to pay back 9% of that. So we multiply that by the placeholder, so I'll drop that in and divide it by 12, so we get the monthly amount. And I got that, I think. Seems a little high. I wonder if I've done something wrong. Yeah, that's 9. So I need to divide that by 100 to actually make it a percentage. £20, 28. That sounds more believable. We'll be able to check in a minute when we get to the end. Okay, and then I need to drop that back onto the final table. Yeah, that value still seems low. Oh, I guess I haven't got the right value in. Let's state that. Let's see. Um, uh, okay, that's looking better. So that's now matching with monthly payment there. So now I want to add that as a column onto my output table. So again, we're going to use the set command. Um, okay, drop that onto the value and give that a name, which is monthly repayment. Great. So this time I want to leave the 35,000 outside of my group. So I want to be able to change that at this level. So I'm going to leave that there. Need to make sure there's a single input here, as I've been doing previously. Just grab those two there. Okay, and if I grab those down and grab this group of tools here, A Control G, let's label that as salary, and then take that for the comment there. Work out what their monthly payment will be. Okay, so now also work out how much interest will applied in the following month after the repayment is made. So I need to reduce, so I had some trouble trying to work out why my answer didn't match the answer provided, and the reason is that the total borrowed plus interest needs to subtract that monthly repayment. So let's do that. And again, we're going to do it in the same way that we've been doing all the other ones. So we're going to take the total, sorry, we're going to take the total borrowed and interest column. We're going to take the monthly repayment column, and we're going to subtract one from the other. Again, we use the underscore trick as a placeholder, drop that on there. And then again, I need the set back. So I take the result of that, which is column, put it back onto my table. And if I give it the same name as the column had before, then that should just override the existing value. And so now we see we've got 55175 30p, which matches the given example up there. Okay, so the last thing to do is work out how much interest we applied in the following month after the payment's made. So now we've got that amount, then again, we can just take the same column and divide, and again, I'll put the placeholder in. And if I come back up here, I've still got this row information. So again, I can add this, grab the interest. I potentially might leave the interest up there, just the visualization, so when people come in to use this, they can see what the interest is. And then I'm going to drop that down into the division. That creates me a new column. Again, I need to do a set. Grab the set. Oh, think in a moment. Did I do something wrong? I think that, no, wait a second, that's the wrong value because that's the original value. Let's grab this one. Okay. Yeah, seems to be thinking a little bit for some reason. Let's just give it a moment. It is live, so I have to excuse the just a quick refresh, see if it helps it out. Okay, restarting. So give that a chance to load up. Okay, there we go. So now we've got, and that looks a little high, doesn't it? What's going on there? 716,000. That seems like a lot of money to be paying back next month's interest. What did we do wrong? So is this value correct? Ah, divided by the interest rate. That's never going to help, is it? Okay, let's switch that to multiplied for two. Oh, and that's the annual amount. So I need to divide that amount by 12 to get the monthly repayment. £354 and 4 pence. That now matches what they had. Put that into my set. And this is interest to be added next month. Okay, so we've got total borrowed, monthly payment, interest rate next month. I think that's our final answer. Perhaps just a quick reorder of those nodes to get the same, sorry, reorder those columns to get the same order that they've got. So we'll do monthly repayment, total borrowed plus interest, interest to be paid next month, and I just need to select reorder, and there we have the answer. So last thing to do, just to finally clear up this workflow, is to group this lot of components. Again, need to create a single entry point of this one. And the interest is coming in. That's fine like that. So I think we'll put that lot of components called G. And this is I need the author. That's as the W. Okay, so we've now got the values, and then we could come in if we want to and change the salary. Of course, with the live nature of Enso, since we change it, we can see how that affects the monthly repayments. We can put it up to 40,000. Um, I'll put it back 35, gives us the answer. So that is data week 12 as solved in Enso. And yeah, obviously some advanced features we've looked at today. Some of the grouping functionality, obviously, apologies for that defect I had to work around. Grouping is a relatively new feature, and we're going to be making a lot of improvements to it soon, so that defect we fixed and looked at some different ways of using it without using the expression language. And yeah, I hope you found it interesting. Thanks for watching.